Our next topic in thermochemistry is enthalpy, represented with the capital letter H. Enthalpy is the energy exchanged in a reaction. Every chemical reaction requires some kind of energy. Either energy is put into a system or energy is removed from a system. This is the change of energy is approximately equal to the change of enthalpy. So enthalpy and energy are related. Note the difference in the spelling in entropy and entropy. If you were to calculate the change of entropy from any given reaction and your change of H is negative, then this is an exothermic reaction. Energy is given off. If your change of H is positive, this is an endothermic reaction. Energy is absorbed.
Famous.
Hey, yeah.
An important topic of thermochemistry is Hess's law of summation. And our next question is relating pollutants produced by cars. I wrote this reaction at the bottom. Cars produce carbon monoxide and nitrous oxide to produce carbon dioxide and a half equivalent of nitrogen. What is the change of enthalpy given these two reactions? So we must manipulate these two reactions, combine them so that they look like this reaction on the bottom, and then calculate our change of H. We first examine reaction A. RXN is short for reaction. We've got carbon monoxide in the reagents. Carbon monoxide in the reagents. So that looks good. Carbon dioxide in the products. Carbon dioxide in the products. Let's look at reaction B. Reaction B has nitrogen and oxygen in the reagents. And we don't have that in our bottom reaction. Reaction B does have two equivalents of nitric oxide in the products, but we need nitric oxide in the reagents. So we will reverse this reaction, and when you reverse it, it changes the sign of the change of entropy from positive to negative. When we reverse reaction B, I represented it by a backwards arrow and a B, we get two equivalents of NO to produce N plus O, and then our change of H of B backwards is a negative value. And then we compare reaction B with the reaction we're trying to get. And if you notice, we have two equivalents of NO, and we only want one equivalent of NO. How do we get reaction B backwards to look like this reaction? How do we get from two equivalents to one equivalent? Well, you can simply multiply the entire expression by 1/2 to get 1. 1/2 times 2 is 1. Now, please remember stoichiometry. Anytime you change the stoichiometric coefficient, it applies to the entire reaction and the value of entropy. So we multiply the whole thing by 1/2. This will give us new stoichiometric values in our reaction. So once we multiply 1/2 through our reaction, we get new stoichiometric values. One equivalent of NO, 1/2 N plus 1/2 O, and our change of H is now 1/2 times negative 180, which is negative 90. Now you examine and see if I were to combine the two reactions, will I get our final reaction? And then you want to examine the two reactions, A and backwards B, and see if we can cancel anything. In this case, I notice I have 1/2 equivalent of oxygen on the products in backwards B, and 1/2 of oxygens in the reagents in reaction A, and that cancels out. Now I can combine both reactions. I've got CO, CO, NO, NO in the reagents, and then that produces CO2, CO2, and 1/2 N2. A negative value and a negative value will produce a negative value. When you combine reaction A with the reversed reaction B, you get this reaction, and the change of H has a new value of that.